Hi guys, I'm Monika, a software engineer, passionate for exploring the creative side of technologies. Currently I'm working at Vivino as an software engineer, where we are creating seamless experiences for wine lovers around the globe through our mobile application. I'm also part of the organizing team for iOSConf. That is an annual iOS conference happening in Macedonia. But beyond my day job, I'm also interested in exploring platforms like visionOS, where both software and hardware converge to create seamless experiences for users. That's one of the main reasons why I'm here to talk today. I'll be sharing my journey on creating a sign language recognition app for VisionPro, and why I truly believe that building with purpose, rather than just porting our existing apps on this platform, makes a big difference. But before we start, let's look into the history of computing. There has been major paradigm shifts happening in a way that how user interacted with the technology, starting from the graphical user interfaces on desktop, going through the touch interfaces on mobile screens. These paradigm shifts required users to change the mindset of how we use technology and interact with it. But the key point here is that they didn't require that just from the users themselves, but mostly they required from us developers to change the perspective of how we develop apps for different types of interaction. And why I'm here to talk about this is particularly for virtual and augmented reality. And in the last period, we've seen many new devices coming out regarding this area. And Apple's response to this news is also the VisionPro device that I believe most of us are aware of. So this device introduced many new capabilities that we didn't have on the previous Apple platforms. And few of them are the eye tracking, the hand tracking, the spatial audio, and the precise world mapping. And there are many more capabilities that came out with this device that are different than the traditional devices we had so far. With that being said, and the way we proceed to develop apps for this platform, I want to give an example of the calendar app that we are all familiar with. The same app is on iOS, macOS, and also on visionOS, presented with a window preview, but does that truly leverages the old capabilities that VisionPro can offer? Most probably not. Now imagine the same app revamped for a full immersive experience when the user can actually have different interactions with the calendar. For example, have a 3D preview of the schedule, walk around the weekly schedule, and see more information of the details about meetings or immersive places of where the meetings are taking place. This probably might not be the best use case of a calendar app, but I'm just mentioning that it's using most of the capabilities of this device that could offer, and that's the approach that we have to take when building for new platforms. But there's a catch. VisionPro is quite an expensive device, and the audience is quite niche for it, at least for now. And that means that we have to build applications that truly bring some value to the users. We cannot just port existing iOS and macOS apps and hope that it would be, they will feel intuitive to the users and fully native for this platform. But before we dive into my journey on visionOS, I want to take a step back and tell more about my background within augmented reality. I had possibility on working on few augmented reality projects in the last few years. One of them is InspectAir, where this is an application for guiding the users to the whole manual, whole automatic inspection, powered by AR features. Another project that I've been working on is a research and development project with Hilti, where we automated the whole process of detecting walls and pipes for automating the fireproof pipe installation process within the walls. This and many other projects that I've been working on augmented reality had anchored my knowledge and enthusiasm for these platforms, and also had spread my interest into the virtual reality world. So when VisionPro was announced, I already knew that I want to take a dive into it and start developing for it. And fast forward just 2 weeks before I had my VisionPro device, I was attending Christian Diaz's talk on accessibility for visionOS. That talk hit me hard because it made me realize that accessibility isn't just about compliance or following measures. It's much more than that. It's about asking ourselves what this new platform can bring to us in order to create and solve problems that weren't possible to be solved before with traditional devices. From this point of perspective, I took some time and I realized that I don't want just to explore the shiny new features of visionOS, but I also wanted to think about creating and building application that truly matters and might help someone. And that's where my idea for a sign language recognition app started to take shape. So once I had my idea in place, I started exploring the APIs of visionOS that bring all the VisionPro's capabilities in life. And I'll just walk you through a few of the APIs that they offer. One is the world tracking provider, which gives accurate tracking of the user's environment. Then we have the room tracking provider that gives us more context of the room where the users are. The next one is object tracking provider. It is tracking and detecting physical objects in the user's environment. Hand tracking provider, it tracks hands, of course, and gestures. And the last but not least is the image tracking provider, where we can anchor virtual content on top of any kind of image that we have defined. So as I mentioned, I wanted to create a sign language recognition, to which I will refer to an ASL, meaning American Sign Language. This whole idea is super complex, so I needed to descope kind of most of it. Probably not everything, but I decided to firstly focus on detecting letters presented with hands. So this was my idea, actually, to understand which letters the user are creating when using the VisionPro. With that in mind, I knew that I needed to find a machine learning model that could help me predict the positions of the user's hand and understand which letter they are creating. And if you go on the web, you'll find dozens of very impressive machine learning models, right, for this use case. But there was a catch. The catch was that all these machine learning models were trained on image sources. And ironically enough, out of all that many cameras on the VisionPro, we cannot access any of that data if we are not enterprise developer. Because of user privacy reasons. So I hit my first wall, and I couldn't use any of these machine learning models. I took some time to think about it, and I got to a point when I realized that I actually can create a machine learning model by myself. With that, and the information that I needed to gather is actually the position of the hands for creating the machine learning model. I chose to work with a hand tracking provider API, which not just tracks hands, but it also provides all the fingers indexes within the coordinate space. And that's pretty good enough because in each frame, I could extract the positions of the fingertips, knuckles, hand base, wrist, and everything that I would actually need for my use case. So let's just give you an overview of how everything works. When the user starts the immersive space, the coordinate system is initiated right at the bottom of the user's feet. I don't know how this works. Yeah, there. Anyways, it's initiated right at the bottom of the user's feet. And that truly matters because whenever the user is moving within their space, everything is being tracked precisely, even his trajectory of moving. The problem here is that I thought that I would have this trajectory being projected on my hand positions as well, and I would need to do all those calculations to get the position of the hand indexes within a frame relative to the hand. But the good point is that the hand tracking provider actually provides a relative hand positions, meaning that each position of the index of the finger is relative to the wrist of the hand. And that was a perfect use case for my scenario because of four-letter recognition. I only needed the positions of the fingers relative to the wrist. Once I had gathered the data, it looked something like this. So I had extracted all the X, Y, and Z axis values for each index of the hand. And I also labeled each row with a letter that they represented. In this case, is A and B. And the data actually looked a little bit more like this. So I had some rough time gathering that data. But once I had my data gathered, I started training my model. And for this step, I chose the CreateML's application, which is Apple's utility application. And it's perfect for those who are not into data science, like me. So it is quite intuitive for using it. Because my data was structured in comma-separated files, I decided to use the tabular classification. Inserted my data and started with training the models. And good point here with CreateML is that it allows you to go through a few iterations, testing out different algorithms. And it's super simple. I ended up using the random forest algorithm. And these were the results. I'm not sure if they're visible. But yeah, it was quite successful results because I got the A and B results with good accuracy. Once I was done with that step, I knew that I needed to scale up to all the 26 letters of the alphabet. And it took some more time to gather my data for all the letters. But eventually it resulted with this. Which is super accurate results, at least for the beginning. Thank you, but it wasn't perfect, actually. There was a little bit of caveat. So two letters, J and Z, they had movement included within their trajectory, meaning that I extracted my data per frame. And the accuracy for these two letters wasn't quite good at all, actually. I knew that I had to take another approach for my solution, and that's taking sequential data and using a sliding window to extract features out of those frames to understand which gesture I was doing at a certain time. So once I was thinking about this approach, I actually thought that I could just include the other hand's position as well, and I can include predicting of words and phrases in ASL, since they are created of two hands mostly. And for this step, I actually used the CreateML's activity classifier because it works with time series data, and it works right as I want it to. So it uses a sliding window where it goes through all the activities from the data. Once the parameters are extracted and the machine learning model is created, I can use this in a real time to predict my words and phrases. So few of the steps were quite repetitive from the previous time, except that there are a few differences at this point. As I mentioned, the hand tracking provider, it gives us a relative position of the indexes of the hands, meaning that I cannot just use relative indexes when working with two hands because it matters where they are in the space at a certain time. So I needed to use some reference points. And for the reference points, I decided to use the VisionPro position within the coordinate space. And to extract its position, I used the World Tracking Provider API where in each frame I could extract the position in the coordinate space that was initiated at the beginning. So this is how it looks at a certain point at time. I would have the VisionPro position, and then each index of the hand, I could also extract the position in the coordinate space, the same as the VisionPro. And with a little bit of math, I was able to actually define the VisionPro as the origin of that coordinate space and the relative indexes, positions of each index of the hand. Once I had this approach, I gathered enough data, and I organized it in a way that was required by the activity classifier, meaning that all of this data was grouped in directories named with the word or phrase that it was representing, with the data being organized. Okay, so this is also the structure of each file. It is very similar as before. This time I just included the time series, and I included both the left and the right position at that time. So one data could look something like this. I would do a back and forth multiple times same gesture, where the sliding window later on would go through all of these gestures and define when I do actually the same activity in real time. So the flow was pretty much the same. I went through createML, activity classifier this time, imported my data, and the only thing that differs from the previous classifier is that I had to decide how long my gestures were lasting. So they were around 2 seconds, meaning that I had 50 samples per second. So I had 50 frames per second. And because my gestures were around 2 seconds, my predictive window size was 100 samples, so 100 frames. Once I was satisfied with my results, it was time to integrate my project within my application. This is quite a simple example of how I used my classifier. So I initialized the machine learning model. Each time it's quite light, but yeah, this next step is the input data. I gather it through the position of the indexes, the position of the device, and once the data was cleaned up and normalized, I just used the prediction method on my classifier, and it resulted with the highest predicted word or phrase at that point. It resulted with something similar like this. So I'm presenting thank you, I appreciate you. While the results were promising, I have to say that this is a very much work in progress, and this is a proof of concept. And there are many considerations that I need to do along the way. Few of them is expanding the training data set. I need a much more diverse data set, not just gathered from myself, but from many other people. So it could be stable to be used from different users. The next step is enhancing the vocabulary, meaning that I need to introduce much more words, phrases that are common in the sign language. And last, and maybe the most important point to mention, is the facial expressions. So this actually matters what the user is doing with the face when they're when they're communicating with a sign language, adding more on the value on how the users are feeling at that point. But that's a problem that I would think in the future for now. And also, one of my goals is to open source this project so other developers can build on top of it, have inspiration, and because I think that accessibility should be a shared effort, and I hope it will benefit to someone. To wrap things up, VisionPro, okay. To wrap things up, VisionPro offers a lot of possibilities, but we are only able to use them if we approach it with the right intention. And this doesn't mean this doesn't offer only for the visionOS. It is about every platform, every old and new platform. Whenever we have a problem that we want to solve, we should stop and rethink the problem, start to explore and innovate solution, and at the end, develop with purpose. Thank you.